Hello, hi, and welcome to another ramble. I have to apologize in advance because it is actually my third take recording this video. And if you're familiar with this channel, you know that the idea behind these videos is for me to tackle questions fresh. I don't want to prepare in advance, I just want to be exposed to the question raw in order to then share my thought process in approaching the question. My big hope with this channel is to help you learn how to choose tools to approach questions. I think it's one thing to understand how a tool works, so to understand how factorizing works, or to understand how other mathsy things work, but it is another skill to then approach a question and kind of decide, I think this technique would work well for this question, or maybe this is a good approach to try. I have no idea what technique to try, but here are a couple of things that I can, here are the places I can poke around and hopefully find a way forward. So the focus of this channel is to help you learn that skill. And I'm not entirely sure how to teach that skill, so I just show you my thinking when I approach these questions, in the hope that you can then deduce or find or extract value, and then turn that into, or help make that feed into your thought process when you then face unfamiliar questions, etc., etc. Wow, okay, ramble number one complete. Also, my food delivery is officially on its way, so we might just hear some exciting sounds in the background shortly. Anyway, so what happened with this particular question is that the first time I tried to record a video, I think about 4 or 5 minutes into it, the construction guys started doing their thing, and I thought that I could overpower the sounds of drills and all sorts of other powerful machinery. Maybe unsurprisingly, I did not overpower all of that. So yeah, I then trashed that video. Then I tried to do another video now, and I confused myself. So this is now a triple refined video, and I'm hoping that it can still be a valuable lesson, let's call it that, nonetheless. So yeah, question 5B from IEB's paper 1 of May 2024. Question 5B. I said that. Right. How many unique ways can the letters in the word dresses be arranged? Okay, so what immediately stood out for me when I first attempted this question was the word unique. Because if you look at the word dresses, it has a couple of repeated letters. The E is repeated, the S's are repeated. So if you had a word like trunk, where it's just unique letters, right? So if we're making 5-letter arrangements, or let's just call them words in inverted commas, we know that not all the arrangements will make like proper English words, but for the sake of not having to call them ways or arrangements or orders or other weird terms. Anyway, so if we wanted to make 5-letter words from these letters, right, for the first slot we would have 5 options that we could choose from. And how I like to imagine these is kind of having Scrabble tiles, right? So you have this bag and it contains these 5 Scrabble tiles, and you reach in and you pull out a tile, and maybe the first one you pull out is the N, right? And so you had 5 tiles that you could choose from, and you chose the N, right? So your first slot, you had 5 options. So now in your bag, you're just left with 4 tiles, right? So for your second letter, you only have 4 tiles left that you can choose. So now maybe you reach in and you pull out, don't pull out the question, right? You reach in and you pull out the R. So now for your next letter, you only have 3 tiles left that you can choose from. So you reach in and you choose. Hey, guys, leave the question alone. Okay, you reach in and you pull out a K. Right. And now for your next slot, you only have 2 tiles left that you can choose from. And you reach in and you choose a T. Okay, and then obvious for your last slot, you only have 1 tile left. You reach in and you pull out the U, and that will be one of the arrangements, one of the words that you could create using these 5 letters, right? Not 2. And so the question is then, okay, how many words are possible, or how many unique arrangements are possible? And that's simple. It would be 5 factorial, right? Because it's 5 times 4 times, 3 times 2 times 1. And because all the letters are unique, we don't have to make any special considerations, right? Whereas, maybe let's choose a simpler bag of tiles. Let's say maybe instead we had the tiles POP, right? If the question was again, how many unique ways can these letters be arranged? So here it would be important to distinguish that, okay, there's this P, and I'm just going to color code it as a pink, and this P, which I'll color code as a yellow. If you reached into your bag and you chose the letter O, that's perfect. Then from there you reach in and you choose this P, and then you reach in again and you choose the yellow P, so that will give you the word up. But you could also create the same word up. Okay, I actually want to duplicate you guys. Duplicate. You could also create the exact same word if you chose the P's. So if you chose the yellow P first and then you chose the pink P, right? So there are 2 ways that you could make the same word, and that is because the letters are repeated. So even though the arrangement or the order is unique, the word or the arrangement or the permutation, I want to say, isn't, right? So naively, we would say, okay, how many arrangements are possible? Well, I have 3 tiles that I can choose for my first slot, and then I'm left with 2 for my second one, and then I only have 1 left for my last slot. So there's 3 factorial arrangements that are possible. That would be the naive approach. But the wiser approach would then say, wait a minute, but for each word or for each arrangement, there's 2 different ways that I can get that arrangement. Either I could start with the pink P and then the yellow P, or I could start with the yellow P and then the pink P. So this 3 factorial arrangements is actually double counting words. So I need to take that 3 factorial and divide it by the number of ways that these 2 P's can be arranged, which is 2. So that would be 3 factorial over 2, which is 6 over 2, which is 3 ways. And indeed, this is the case. Either I end up with op, or I'm going to end up with pop, where it's pink P, O, yellow P, or yellow P, O, and then pink P. Or I'm going to end up with PO, PPO, or yellow P, pink P, O, right? So that is the importance of this operative word over here. Is we're not just looking at how many ways the tiles can be arranged, we are concerned about what that permutation then looks like. Yeah, that doesn't really make sense, but anyway. Too tired to try and clarify. Hopefully by doing this example I can clarify what I was trying to say. Okay, so we now have a Scrabble tile bag that has 7 letters instead of our innocent 3 letters, and the E is repeated. So we have a yellow E and a pink E. Okay, and then the S's are also repeated. So we have a green S, a purple S, and a red S, right? So for any word that we can create from these 7 letters, we need to remember that there are multiple ways that we can pick the tiles that can create that word. So even the word dresses itself can be created in a number of ways. We could pick the yellow E and then the pink E, or we could start with the pink E and then the yellow E. And then there's also the S's in the mix. We could start with green S, purple S, and then red S. Or we could start with green S, red S, and then purple S. Or we could start with the red S and then pick the green S and then the purple S. So what I was trying to say earlier is that the order in which we pick the tiles, the order in which we pick the repeated letters specifically, to the naked eye that is just reading the word that gets created, it doesn't really even matter that we pick the yellow one first and then the pink one, or the green one and then the red one. And no, that doesn't matter. All we are seeing is the word dresses. So we need to eliminate those duplicate counts of the same word being created by different orders of the repeated letters. So what we need to figure out is, okay, first of all, naively, how many arrangements are possible? There are 7 slots. So in the first slot, there's 7 tiles I can pick. Then in the next slot, I'm left with 6 tiles that I can pick, and so on. So naively, there are 7 factorial arrangements of the tiles that are possible. Okay, but now we need to think about, well, for each word, how many different arrangements of the tiles create that same word? So first we need to think about, okay, in how many ways can these E's be picked? In how many orders can they be picked? And because it's just 2 of them, well, so it's either going to be the yellow E and then the pink E, or it's going to be the pink E and then the yellow E. So there's 2 ways that the E's, let's just say 2 orders for E, okay? And then what about for the S's? So for the S's, there's 3 of them, 1, 2, 3. So in how many orders can I pick the S's? For the first S, it's either going to be the green one, the purple one, or the red one. So I've got 3 options. Then for the second one, I've got 2. And then for the last one, there's only 1 S left. So there are 3 factorial orders for S. And so for any word like dresses or other words that are nonsense like accessored, right, there are 2 times 3 factorial ways to make the same word, right? So the idea there is for any word, we could have yellow E and then pink E and then one of the 6 orders of the S's, or pink E and then yellow E and then one of the 6 orders of the S's as well. So those would all be different orders for E and S that would give you the same word. So 2 times 3 factorial is 12, right? So there are 12 different orders that we can pick the tiles in that would yield the same word. So now we need to take that 7 factorial and divide it by the 12 in order to give us the unique words that are possible. And I think I calculated that once before. Okay, calculator is dead. So that is 7 factorial divided by 12, which is 420, and that is our answer.